we go. Cool. So I'm here today to speak a little bit about Module Federation and dive a little bit into its uses in server-side rendering. So let's get into it. All right. So I think just to go over the basics, which it sounds like everybody in this conference already kind of knows micro-frontends, and sounds like from the questions I've heard some familiarity around Federation. But quick recap. General motivation behind why we built it was we needed something that would really allow us to share code in a convenient manner. And if anybody has tried this at least a couple of years ago, it was quite a tricky kind of challenge to get running smoothly. So really what I was trying to look for is a way to provide autonomy to independent groups, a manner of orchestrating in a stable, predictable way, the ability to share dependencies, and a way to try to mitigate the UX drawbacks that we've usually seen before with things like externals or multi-framework or anything like that, where you start to really drag down the web performance. So for a little context, we could say this is a theoretical application that we've got. Each square could represent a different team or a different group that wants to push independently. We have things from components to style guides to business logic, all in there. We want to move each piece independently. As you can see, these applications or parts could be split in various ways. And really what I wanted was something that more or less just works. Don't really have to learn a big framework around it or have to drastically change the base engineering practices that most developers are aware of, which to me is being able to require import code. So that's kind of what I wanted to keep everything as, is why can't I just require this code? So the kind of problem that we ran into here was there were a couple drawbacks with the solutions that were currently available. We have the single build, which is, of course, really big and slow. Any change that is made requires a full rebuild and a full redeployment of the whole system, which can be quite disruptive when you have a large group working inside of a code base. We have the DLL plugin and externals, which is kind of like the older way I think a lot of us did micro-frontends to share things. Big challenge with that I've always run into was there was a lot of manual work. If I wanted to, say, share React or something, I'd have to synchronously load it in as a render blocking script and make sure that nobody else has it. And that does create a big blast radius issue, because if you need a dependency that isn't vended on the page ahead of time, the application will fail. And there was no way to really kind of fall back. And then we got to native ESM, and I think native ESM has come quite a long way, especially since the creation of Module Federation. But I still do see a couple drawbacks in there, usually around just the web performance side of it. There is a lot of network requests that usually come from it. And there's a couple other things like preloading and things that you do have to take in consideration. So I wanted something that was also more platform agnostic, not really leaning on what the browser can do or what anything can do, but what could I get that would really provide what I'm looking for across anything capable of executing JavaScript. So what I was really looking for was some kind of a scalable trade-off. And this little graphic that Jack Harrington made back when Federation was created is a really good way to kind of visualize what we're trying to get, which is really, I want to be able to pull this code into another user base on the fly. We have several different ways that you could do that, through edge side includes or through libraries or things like that. But what I really wanted was kind of the application to also act like a NPM package and be able to vend individual parts of it out without having to really change the development flow of the team working or owning this part of the stack. So this is where Module Federation kind of comes into the fold. So briefly, what is Federation? The idea behind Federation is originally I got the name from looking at Apollo Federation. That's kind of what I wanted, was the similar concept to it. And really inside of Module Federation, we have 4 main terms that are often used. We refer to something as a host, which is typically kind of the first Webpack application that attaches to the page and consumes other parts. We have what we would call a remote, which is just essentially whatever's getting consumed. You have a bidirectional host, which can kind of either consume or be consumed. And then you have the kind of last thing that we added to Federation before the stable release of Webpack 5, which was this concept of omnidirectional hosts. So the idea is that it can be anything at any time in any manner. So the main difference between like an omnidirectional and a bidirectional was in an earlier version of Federation, we did not have the ability to dynamically share the vendor code. So the host could provide React to somebody else, but you would always have almost that external factor. Omnidirectional came along where the host itself doesn't even load its own vendor code that is shared, and it negotiates with everybody else to figure out who has the most viable dependency, and then that dependency is loaded in and everybody uses it, including the host. So that's kind of why we call it omnidirectional. It behaves similar to a remote, but it can operate in host mode. So the real goals that we were trying to get out of Federation were dynamic sharing, importing foreign code, and deployment independence. Obviously, a lot of this stuff is at runtime, which is where we get the most flexibility and the most instability if you don't have the right guardrails on it. But some of the other things that we wanted to also improve the challenge that comes with at runtime self-forming applications is I wanted the ability to either be able to version or make these things evergreen. So, have some form of a runtime lock file or something similar to that. I wanted some level of redundancy, should have capabilities that it can self-heal. And I wanted to really, again, try to keep the developer experience acceptable without a big impact on the user experience. So the overarching thing I kind of mentioned earlier is I really wanted something that just works. So by just works, I mean it should work everywhere, and it should be simple, relatively speaking. So usually when we run into web architecture, I found that we're limited by the lowest common denominator's capability. And for the longest time, the lowest common denominator has usually been Node. So Node has to have the packages on disk, so we have to use NPM for everything to distribute it. And we have to work around that with things like edge side includes or network stitching or template stitching, things like that. And it also creates this kind of weird inconsistency or fragmentation between how things are really implemented. Because and this is something I really didn't like, is when I have to go and implement, say, a micro-frontend stack and I want server rendering, how I build it for the browser is quite different than how I would have to set it up for the server. So, you always have to kind of double architect certain aspects of it, and you can mitigate the amount of double architecting you have to do, but it's not just I require the code and it magically works. Either have to do some package thing or, get more infrastructure involved or edge infrastructure involved to try and solve it. So by simplicity, I really wanted, how you do it in one place is how it works everywhere else, and you don't really have to think about anything beyond, in this case, importing the thing that you want. So an example of the simplicity that I'm kind of talking about here, here's a few examples of like configuration. Really, I've got application A, application B. I'm going to set up some shared dependencies. Inside of Webpack, we'd opted for double opt-in on the sharing. So both parties have to agree that they're going to share, say, React, and under the rules of which they're going to share it. This helps kind of ensure that there's some kind of a contract on what we agree is going to happen and not going to happen between the different applications. We don't have unexpected side effects that another party might not have been inclined to accept. So inside of here, I've got, application B referencing as a remote, and, in application B, I'm exposing button and drop down. If we drop down into it, you can see here's sample of importing it. We can either do a dynamic import and lazy load it, or we could do like an eager import and just statically pull it in. So if it's lazy, obviously I'm using suspense or whatever I want. And for drop down, you can see I just use it as if I would use anything else in a synchronous manner. So some of the alternative kind of configurations that are, some we've seen, some are less familiar, but are quite powerful, is, this is probably the most popular one that I use today is the at syntax. Pretty much you have the global scope, so core, whatever the namespace is that Webpack will be able to find this under at runtime, and then the script URL, so Webpack can either see if it exists or inject it if it doesn't, and then resolve it to the namespace it's going to show up under. We get into a bit more of an advanced scenario. You can get the syntax, I just call it promise to promise for lack of a better word, but you can also pass it a custom promise. If you give it a custom promise, Webpack is going to sit here and wait until this thing resolves. And what it expects to resolve is the interface to another remote. So you can now include your kind of own logic into how Webpack actually resolves this. And this runs at runtime, which is quite nice. So you don't really have to statically code anything. There's also a interesting kind of theory that I've played around with and used once or twice, but it's the idea of using federation to power federation. And so there's a couple different ways that you could do this, but in a simple example, if we use the promise to promise syntax, I could have a remote that I load inside of this promise, and what that remote resolves to is kind of like the routing logic for connecting remotes to other hosts and so on. So you can then extract all the kind of all that platform logic that you would want. It could actually be put in its own file that is also updatable at runtime in real time. And that's what actually drives the connection logic between your applications. So it's quite useful when you're trying to get, larger scale, more complex, more intricate kind of application logic in there. So promise to promise was great. I used it for years, but eventually it started to become suboptimal. You can imagine if I put everything in a template string that it's going to run into some issues at some point. And that's pretty much what ended up happening. After a while, my template string ended up being like 250 lines long, and you've got no transpilation in there. Require doesn't work. So you really have to be careful that whatever you're putting in that promise logic is actually going to run in the browsers that you want it to. And it's also really hard to look at because there's syntax highlighting if it's a giant string. So this is kind of where we took the next jump and I started to build out something called delegate modules. And so delegate modules is a very similar concept to the promise near promise, except it's actually bundled and processed by Webpack. So what a delegate module can kind of look like is this. So inside of Next.js, this is essentially how you could access the delegate module. You could use create delegated module. You can pass me your own, JS file pointer. And then you could pass me metadata that I include into this when it gets built. So now it knows what it's supposed to do. Now, in this case, delegate.js knows what Webpack's asking for when it tries to go and reach out and get shot. If I didn't do that, I'd have to create like an individual file for each one, and that totally works. But usually it's a very standard piece of logic that you want. So this is kind of how I would implement a delegate module. And on the flip side, this is kind of what a delegate module looks like when I'm using it. So I have my own file somewhere in userland that I have access to. And all the object properties that you pass inside of the config is translated into something we call a resource query, which kind of just turns it into a query string that Webpack injects during compile. So now I can use that to pull the information back out and kind of control the delegate module and what it's doing. So it's aware of what the current request is going to be. So with the delegate modules in place, you can see I can also now use import, and I can use ES6, and I can use whatever else I want. And in this case, I'm actually using a delegate module to connect to a service I have called Medusa, which is kind of like a central brain command and control system for Module Federation. So in this case, it's a API call. So whenever Webpack sees a federated import, it will make an API call to Medusa saying, I'm this host, I'm currently looking for this remote in this environment. And Medusa can respond with the @ syntax or global in URL. I can split that apart, pass it into the import delegated module helper, and that will return a remote entry interface back to Webpack. So now all of my orchestration and formation is controlled through an API, through a system built to manage it. So delegates are super powerful for doing various things. I've also tried a couple non-standard things of kind of hacking the federation interface. So one of the really cool examples where I found delegate modules to be useful was in Cloudflare, where I don't have a public working library for Cloudflare Edge and Federation. But using a delegate module back in the day, I had tested out the theory of what I export back is the kind of remote interface, the low-level one, the whole get and init object that it gives back. But whenever Webpack would call a get, which expects it to retrieve your exposed module, I just hacked the interface, so it was actually a little proxy. So I would see, hey, you're looking for nav, and what I would translate that into is a fetch call, and I could kind of switch back to some of our more traditional ways of doing micro-frontends. And I was able to actually go fetch the HTML and I would return it as module exports. So I would get back the markup on the edge from another edge worker, and I could send that back or convert it into like a dummy React component really quickly. But Webpack still requires the code and gets what it thinks is there, and the parent application could still render it, even if there's certain constraints on the system that don't allow Federation to work as you would anticipate in that environment. So delegate modules are really powerful. The easiest way to sum it up in like a sentence or two is it gives you control of the glue code between the Webpack runtime and the thing it's going to connect to. We've seen probably the concept of dynamic remotes, where you can kind of inject the remote on your own, and then you can use the low-level interface to get whatever you want out of it. And a lot of users use dynamic remotes because they want to be able to change the URL that they're injecting on the fly, depending on an environment or depending on certain scenarios. But what they're trying to actually pull out is usually statically written. So they could just use import from if they could have something to, like some kind of programmable logic gate to change what import from means at runtime. And so this is kind of where I see delegate modules to be really helpful. You still get to keep the whole import syntax, and it feels very natural. Webpack handles most of the hard work for you, but you have that ability to change the glue code in what it means in the context of whatever you're doing. So if you don't need that full dynamic control where you don't even know what you're going to import at a certain time, and you only want that partial programmatic dynamic control, delegate modules is fantastic, in-between balance for most users. So when would you use federated modules? So there's quite a broad use case that they can serve. But I would say if we're speaking just in the micro-frontend realm, some of the obvious ones that I usually go for whenever starting somewhere is global components, because these are typically high friction. So header and footer, everybody needs it. Having to go around and redeploy multiple applications or multiple stacks, anything like that, it can get quite tedious. So they're global, they're usually quite isolated or independent, so they're a really good candidate to reduce some friction right away and still be something that's safe enough to kind of experiment on. Obviously, features owned by different teams, working across several different flows. It's a great candidate for. Horizontal enablement's also a really good place, and actually, this was the first place when after I'd built Federation, that's what I went for, is fixing our A/B testing. So we didn't have to use like a tag manager or patching the DOM with document write or append or whatever, but rather have the personalization and A/B test teams and analytics teams be able to write first-class, first-party code that we would consume as if it was our own code. So now we could create really rich experiments, really rich experiences. We could integrate analytics a lot deeper into the application than we could usually do when you're having to rely on the way I refer to it is when you have to do something that's outside the scope of React. So from outside of like the closure of your application, I'm having to rely on DOM events or click events or other handlers that I have to tack on to this application. And what you end up seeing usually, especially with third-party code, is you have a kind of a resource fight because we only have one thread. So now you're kind of balancing code that can't work within React super well against the actual application that brings in the revenue. So being able to have these things kind of work in tandem together was a big unlock for performance, allowed us to do a lot more things, and allowed us to remove a lot of kind of overhead that we didn't really need anymore. And then the other really great thing for Federation as well is just as a migration tool, moving from a monolith to something else, or moving from framework A to framework B, or major upgrade to a new stack design. Let's say you're going from create React app to Next, but you can't just pull everything over right away. You could use Federation to kind of bridge the gap as you made your transition over, which is really helpful. I've also, in the server side, I've used it quite a lot for multi-threaded and high-density computing. Since I can access the code base on any thread, and I can dynamically change what that code base is on every thread, I can just hand over work and auto-scale the computation effort as needed based on whatever's going on. As soon as I hit a certain limit, I could just hand it over to a new thread, and I don't have to like build a worker loader or think about how I'm going to build this to make certain things offloadable. It's just Federations just exposes this interface. So whatever I need, I can just access, and I don't really have to, again, get into like the nuances of the build mechanics a whole lot. I could just use the Federation mechanics, which are a whole lot easier to manipulate after you've played around with it for a little bit. So I think we kind of brought, in the previous talk, they had brought up, somebody had asked the question around, like, how do you test micro front ends? And, there's that example of the dashboard. And this is a challenging scenario that you have to think about, which is, okay, well, if teams are using it elsewhere, am I going to double test it? Unit testing isn't, a perfect fit for micro front end always, unless you're going through like an NPM type workflow. So testing gets a little tricky, but I would say the thing that I would say sits on top of that is it's the stability concerns and how we design the components to begin with. So what I usually do is I call this model for taming the monster, component level ownership. So the idea with component level ownership is really we're going to push things right instead of pulling it left. So the components become a bit smarter. We create smart components that are more self-sustaining. They operate similar to how you would do like an iframe almost. That level of, it will run on its own. It's not highly dependent on implicit dependencies passed through, so on and so forth. In component level ownership, what I want to do, especially with how I build out federated applications, is I use the polyolithic style. So it works like a monolith at runtime, even though it's a distributed system. There's, of course, many different ways that you can use federation. It connects JavaScript from point A to point B. So whatever you want to do with it, if you want to mount applications or you want to do polylith like I do, it's your call. In polyolithic design, there are more concerns to think about. So this kind of is modeled toward that, but it's applicable in several places. So what I want is the smart component idea. The component should be able to run independently of its environment. I should be able to pop it into Create React app and it will continue to work. I should be able to put it in another app or somewhere else in a different feature and it should continue to work still. I want to co-locate everything. So it's logical, it's easy to find. It makes sense. I intuitively know if I need something around, let's say price, I could go to the price component, and in there is the logic that I'm looking for, that maybe it has the API call or some other things. Keeping it loosely coupled, that's a really big one, especially around the implicit dependencies. Again, in my world, I'm trying to take the best monolith and the best micro front end and not really take the worst of them in. So even though this is a polyolithic design, I'm only leaning on the monolithic structures for things like the in-memory buses that I can create, or the ability to cascade context down. But I'm not using context in the way that you would use a monolith, where it's always going to be reliably there. I really want everything to be really explicit in there, but I want to create more efficient communication channels that are properly controlled. And then again, the other aspect is going to be really trying to define those ownership boundaries. This is where things can also get a little tricky if you have lots of components, is who owns this block and where is it going to live, and where are we actually going to split the application and create these ownership boundaries around, which would turn into deployables or at least exposed modules from a remote container. So looking a little bit into a really basic example of what component level ownership could look like. Let's say this is a very simple product page and I've got some purchase attributes, and you can see very general, I'm taking all the props, I pass them to the component, and we drill it down and off it goes. This is kind of what I would try to build out in a CLO world. The idea would be, instead of giving it all the data and it being a dumb component, what I would want is for the team that's exposing it to treat it similar to how they would treat a library or a service. I'm going to pass some basic hints about what I need this purchase attributes to do, but it's going to actually take that and do the heavy lifting. So if the data structure changes, I'm not really going to be impacted by it, because I'm only passing very primitive hints of, hey, this is what I need you to do. This is the product ID and this is the color. Now go find the product information and all the attributes and display them. So if you shrink that surface area of the API, stability becomes a lot more predictable, I would say. You have less chances of things breaking. And usually when I'm speaking to teams, it sounds scary, but it's a good way to just frame it up mentally, is always say, try to build out your software in such a way where anything could change at any time without notice. And if you do that, you start to really get into like resilient software. Boundaries, unhappy paths start to come into thought. And we also start to think a little bit more about, well, what do we really need to expose versus what do we actually need to derive the result being requested. So inside of a component level ownership component, this is kind of what I would almost export out. The idea would be, okay, I have some kind of a data fetching utility. However, I'm going to actually get the information that's being requested. I make that available just in case. I also make the dumb component underneath it available, and then I would kind of default export out the smart component. And really all it is a combination of dumb component plus some way of fetching the data in an isomorphic manner, like suspense, or older, you could use server-side effects. But the whole idea is it's really just a combination of the two that's more self-sustaining. And I can pass in some props, which fill in here, and it now will pull back the information I'm asking for in such a way. The reason I like this kind of 3 export rule really is so that I can keep the flexibility available. If somebody does need to create a new component and they just want the data that powers the current component, they have that option to still access the primitives, or they could compose the data and the dumb component together and wrap it in something and kind of pass it back. So it gives enough flexibility if needed, but most use cases that I've seen, everybody just goes for the smart component, and that's all they really need. So the one extra thing that I usually add on to the CLO concept here is I don't direct expose the feature that I'm trying to expose. What I'll do is I'll create another folder. Usually my strategy is I create like a folder called federated or exposed, and I just drop little files in there, like expose purchase attributes. And what it does is it actually imports the real feature, wraps it in a additional function body, and then returns the underlying thing that I'm after. The main reason I do this is it does give me a opportunity to deal with, say, backward compatibility or any change management that the providing team might want to cater for, without having to keep all of the either validation or compatibility logic or all of this stuff in the feature. The feature doesn't get messy with the what ifs, but rather we could say, well, there's kind of like a proxy module here where if we changed, SKU to inventory ID, or if we change these prop names, I could switch them out without having it to impact the upstream consumers, and nobody has to change anything. So whatever I do down here, I can kind of translate it back to the agreed upon contract that's available, and it's more or less out the way. The other nice thing as well with this kind of a model is it does give you a way to create your own unit tests, because now I might not want to pull in the federated module and run a unit test on it. And if you've built out something with CLO under the kind of paradigm that it encourages, you shouldn't really need to run a test on that piece of code inside of another environment. But what you'd want to do is verify that you have not broken your contract. So now I could unit test the contracting portion separate from the actual feature itself, and I don't have to worry as much about testing the implementation between A and B. So that's the federation aspects in general, going a little bit into the architecture side. So let's switch it over a bit into the server-side rendering aspects and seeing what does this kind of look like when we tie it together. I've been using Next for the past couple of years, so Next has been where I focused. And so it hasn't been the perfect fit, but we've made great strides in supporting it correctly. So here's what it would kind of look like, here's what we're going to basically render with server rendering, everything that you would expect from a normal Next app. This is what the composed page looks like. Essentially, we have an application called checkout. We have another one called navigation. We have like a hello component or independent remote, and we have like this home component. And so you can see the different colors here kind of describe the different bits and pieces. We have the share scope aspect, which is where the omnidirectional remote like vendor negotiation takes place. And on the side, we have the composed result. So if we break that apart, this is what it looks like if we were to think about the repo structure. Each color, each block is essentially its own kind of repository, and that's how it's going to get consumed in. So the hello component is actually not consumed by checkout, but it's consumed by home, and home is consumed by checkout. So we have this kind of nested or cascading remote scenario that starts to pop up. And while that's powerful, it does also create some other interesting things to think about. So one of the big ones that I always come to is like, well, how do you manage the versions between these things? Because it's probably going to come up at some point that I'm going to have 2 things from the green remote, and they're going to need to be at different versions if the company's large enough and there's enough bureaucracy in the way of just shipping things out. I might need green to be at version 2 here, but maybe I have green also in the mega nav and I need that to be at version 1. So how am I going to tame this, especially when it's cascaded down and it's very nested? So that's kind of where Medusa had come in to help provide, to help provide a solution to this, even when it's in a nested scenario and it's relational to its consumer, not relational at a global level. So if we look at just an example of deploying a server-rendered federated application, what I've got here is pretty much a host remote. Right now I'm an independent remote, so I'm going to change this little title from a presentation I did a while back, because the demo is still very short and sweet. But I'm going to paste this on here. I'm going to commit and push this to independent remote repo. Independent remote has no server or anything like that. All it is it's just going to build the artifacts that I need. And then the thing that actually consumes independent remote has not been redeployed. So this is the host. It hasn't been redeployed for a couple hours or minutes. And when I refresh it, both on the client and the server, I get the updated result back. You can see there, that one was last deployed 13 minutes ago. That one was deployed 1 minute ago. And if I look in the HTML, you can see that it actually did server render the update. And so this is all happening pretty much automatically. I don't have to notify Lambdas or whatever environment that so-and-so redeployed. There's no need to do a rolling restart just to get the code back in or the update back in. All of this is kind of picked up on the fly, and when it detects that one of the remote containers has changed, it will automatically refetch the new chunks and render everything accordingly. And usually this process is taking 3 to 4 seconds to reflect a change. So whoever consumes it doesn't need to redeploy, but I never cause a hydration error, and I never really get out of sync. So that's all great, but the command and control aspect becomes really important at runtime. And so this is kind of where Medusa comes in to take what we've seen so far and try to put some more guardrails, some more observability, and just some more visualization around it. I think NX has a really nice developer experience. One of the things I love the most about it is that they have that graph that they can visualize how your supply chain is used. And so how do I do that when I don't have a repo to scan? How would I do that at runtime when things can dynamically happen, change, connect? And so this is kind of where Medusa comes in to try and offer something similar. So every build that you create, there's a plugin, there's the Medusa plugin, which sends some data back to Medusa. And as each build pops up in real time, this graph or UML will start to add things, show things, change arrows, whatever's going on in the system. But now it gives me a very clear understanding of, okay, what is my stack? Who is consuming what? Who exposes what directions are things flowing in? I can also click in one level, and now I can see, well, there's the shell. What does the shell directly consume? Okay, it consumes these highlighted nodes. And then I can drop into that node, and I can even see, okay, what does it depend on? Which file in the code base uses that, and what is it dependent on by? And I can also now see the commit hashes, which is what I use as the version for the remote. So usually you'll see in remotes, I've got like the @ syntax, like home : home @ HTTP. So inside of Medusa, it actually takes over with its delegate module, takes over that control of that. And so the name of the remote is actually the commit hash. So I have no idea what the remote's called. I know that the application is called checkout, but I don't know how to actually reference it as a human. Instead, Medusa is taking care of it. So this ensures that there's never any collisions in namespacing so that I can have multiple versions serving various different pieces of the application without any kind of collision, and let me provide some kind of a lock file. It also lets me see how things are consumed and what version these things are consumed at. So in one other example here, let's see the same kind of server-side rendering. Let's see the same server rendering thing, but let's do it with Medusa rather than just pushing something and relying on the evergreen. So this is what if I click into a page, this is what one looks like. I'm going to click on the green. And now I'm going to go back to the shell, and I'm just going to reload the page a couple times until I see the update happen. So now I've essentially rolled back or switched the deployment of the header in here. And I haven't redeployed anything or anything like that. I've just changed the glue code rules inside of Medusa, which now powers Federation. So then the only thing I have to do is wait for Medusa to propagate the change out. And when I refresh it enough times, so usually like maybe 5 seconds or so, you see the change propagate into the browser. And again, that's also hot reloading it on the server, so the hydration never tears. So some of the things that we've started to look at, and this is a very simple demo of it, and hopefully I think in the next major version of the Node plugin for Federation, we'll add support to this, but it's edge worker support, especially for things that run on Dino deploy, because we have support for that already. So here's a very quick, spent 10 minutes kind of putting this together, but in here, I'm pretty much using Federation at the edge, and you can kind of see the 2 different timestamps and when these components were either pulled in or last executed. And so this allows me to use an edge worker, but overcome a lot of the limits that I've faced with them. A big limit I've always seen is, well, usually they like to be one file, and that file has a maximum limit. And if I use anything like code splitting or dynamic import, and I can't force it into a single file that fits on the worker, I can't use it. Or if I just need something where I need a file system for some reason, it becomes very tricky to use these edge workers. So with this, with this Node plugin and essentially what I added to it, it lets us basically do code splitting on an edge worker. So whatever you want to do, either Federation or even not Federation, if you just want to import a JSON file that's a separate file, the Node Federation plugin adds a transport layer to the edge worker that allows it to have some kind of a file system for all intents and purposes. So this is quite powerful, because then I can also stream this stuff. So as Federation pulls these components in, I can still send a readable stream back with whatever's available, and I don't have any kind of blocking or anything like that. So it works very similar to how streaming a normal React application with some suspense or whatever, how you would expect. So going a little bit forward into kind of what's where I see things potentially going. A really exciting thing that popped out earlier this year was the introduction of RSPack. This really caught my attention, of course, because I'm a big Webpack person, so anything Webpack I really love. And so RSPack popped up, and it's essentially Webpack's API just written in Rust. So it's got full interoperability, or I think there's still hooks that are being built out for it, but the whole idea behind it is that it remains interoperable with Webpack environment. You can use the Webpack loaders, the plugins. In most cases that I've used RSPack, it's about a 5-minute switch from a Webpack ecosystem to RSPack ecosystem. And the speed is quite impressive. I believe the team has worked quite a lot over the past months and even improved the speeds further. But if we're comparing this to, say, a normal Webpack build or something like that, you can see that that speed aspect really is refreshing to see, especially if we're looking at like a cold start or a cold build or something like that. Really shrinks those times down to what we're seeing with the more native tools these days. Like I think a big reason that Vite is so nice and well received by the community is it really did go after some of the bigger frustrations that we've had in the bundler space. It tried to balance out the power and the speed aspect. And it provides a decent developer experience as well. So seeing RSPack come into the play here, it's quite nice to see like a Webpack derived version of a fresh take on it. If we didn't, things like CSS are kind of built into it, or Sass, things that you would expect that we should just have part of the bundler now, come as built-ins. So it's a whole lot less surface area, which I know is another big kind of concern with Webpack, is just to use it, you got to spend like 30 minutes setting up the config. So it's very nice to see this come along with very much out-the-box feel to it. Pop it in, within 5 minutes, I've moved a giant application over, and I'm getting 10, 20 times faster build speeds without having to re-platform or really do anything else other than change a couple words. So I'm definitely bullish on this. In fact, I'm so bullish on what's going on over there that I am joining ByteDance to work with the infra team on their very large offering that they've got. We all know, or a lot of us know, of RSPack, which is kind of the most publicly known one, but there is a very large stack there that could be tied together into something quite impactful, I believe. So I'm very excited to go over there and start investing a whole lot more in this ecosystem and seeing what we can do, and we have a bit more control over the various supply chain parts needed. I think we've seen some great successes with others who have control over their own bundler and what they're able to do with their frameworks. If they control that bundler, is quite impressive. So I'm very excited. Definitely a big jump, but I believe that what's happening here is something that I'd like to be part of, and I think it's got some legs. All right, so in the works, what's kind of going to happen moving forward? We obviously have RSPack, Federation support, Angular support is nearly done. Looking at our edge worker support, there is a new major version of Next Federation coming out, version 7. I'm very happy that in version 7, I've been able to kill off most of the dirty hacks that I've had to use for the past 3 years. And in version 7, we've been able to fold it back so that Federation works the way it was designed originally in Webpack. Now it works in Next. We have a much more elegant way of doing that doesn't involve spinning up extra builds or hacking it or trying to do workarounds, but we can do, we even actually added some features that I'd love to see pushed back into Webpack. Things like, if anybody's used Federation, usually to share things, we have to put that dynamic import at the top of the file. Otherwise, you get the eager sharing problem. So in Next, I have no way to put that dynamic import anywhere because the framework is so high up and it's very much expecting to receive synchronous exports back. So I have no way to load it in, which created a huge number of problems. So in Next Federation 7, I actually came up with a way to make Webpack startup asynchronous regardless of the implementation of the framework. So now I can share React in a non-eager way, and Webpack itself will wait for the requirements of the entry point coming into it to be resolved before it actually registers the entry point into Webpack's runtime, which is exactly what we do when we wrap a dynamic import around our entry point, is to say, go get the requirements, hold the application, and then resolve the final effect. So now we found a way to do that, which I believe will unlock Federation's reach to several other code bases that might have a similar kind of constraint where you can't necessarily make it async to get all the sharing and whatnot to work. So I'm looking at trying to extract that into its own plugin itself, or bring it back into Webpack or something. But now it would, you just drop it in and Federation works the way it was intended. And you don't have to change anything in your code base to get it up and running with the normal sharing omnidirectional mode. Also with delegate modules, Next Federation 7 uses delegate modules by default. So if you are a user of that library, you don't need to worry. Whatever you pass me, I just translate it into a delegate module. So if you want to add your own delegate module, you would just use the syntax or, in our docs that we've got. But if you just pass me like an @ syntax, I convert it into a delegate module, and that's what runs it internally. So I want to take that whole delegate module thing and extract it into its own little plugin or little tool chain so that it's more helpful to non-Next builds. We're also looking at doing supporting Medusa for things like, Angular has a SoftArcs native federation. We're going to look at tailoring Medusa so that it does support all the other framework or micro-frontend type implementations out there, and it doesn't just serve Module Federation or just serve the Webpack ecosystem. And then I think lastly is something that's been developing in recent time, which is really great, is AWS has been collaborating with me and a few others on a service discovery from AWS. So we were able to take some of the case studies of Medusa and see, well, how could we apply that into something that's more agnostic and more broadly helpful for AWS user base. And that's come along really, really well. So what I'm going to look at doing, or a top priority, is to make Medusa return AWS service discovery schema. What's really cool about the service discovery is it's similar to kind of like almost a Terraform, but it's designed so that the front-end build process and the deploy process and everything else all can reference the same schema. So if I create this JSON file that I would pass to the discovery service, Webpack can also read that JSON file, figure out what should be federated and how. And then when I'm deploying this thing, AWS reads that and sets up the S3 buckets, the step functions for progressive rollout, basically all the infrastructure that you would need for running a micro front end, this thing can stand up, including commanding and controlling the actual micro front end itself, all the way down to my delegate modules, wires up nicely directly into AWS's new product. So I'd love to add a GUI to that through Medusa and have Medusa just be able to return and allow you to just scaffold whole front end stacks on the fly immediately by just having Medusa send the computed payload to AWS and it will form your infrastructure. So I think that's really exciting because I know a question I often get is, well, how do you deploy these things in production? And cool, that's kind of all I have. Hopefully relatively short and sweet, but thank you. Oh, I've lost the audio here. Or you're muted.
Thank you very much. Yeah, and thanks for the talk and the interesting content, and also sharing what's coming up in the future around Module Federation and all what is in works. And then also from my side, congratulations for making the next step. Yeah, then what's left is a series of questions. So in the last few minutes, there are piled up a lot of questions. So I guess let's get started with the questions.
Let's do it.
Yeah. Okay, first question. How would Module Federation work with strong TypeScript typing in Next.js?
So there is a, I think there probably is some room for improvement on this. I haven't tested the Next mixed with, we do have two TypeScript plugins for Federation. We have a native Federation TypeScript plugin, which is a bit newer, and it's not so Webpack oriented. It uses unplugin, which is like quite nice to allow this thing to work across multiple build ecosystems. That's kind of what all of native Federation stuff is kind of built off of under my, most of this development happens under Module Federation / Universe. So anyway, if you're looking for, how to deal with typing between federated things, one of the two TypeScript plugins in there would be a good place to look. There's also a couple tools I've seen on NPM around that are like more CLI oriented that allow you to kind of synchronize types into like an @types mapped folder. But yeah, so those are the usual strategies. The ones that are built in there do it in a plugin. So by running, next dev, any types of any remote entries are synced on the fly in a similar way that the remote entry is delivered at runtime. You're getting the types delivered at runtime to your environment as well. So they're always in line with the thing you're consuming.
Okay, thank you very much. So let's get the next question asked by Pavan. Any working example of a ESI replacement of fragments which has their own API at server and caching?
I don't have an example of it, but you could definitely do it. I think the famous question that you always, or the famous reply you always hear in engineering leadership, well, it depends. So I would say this scenario very much depends on how you've modeled things. But let's say if we were doing something similar to like that delegate module kind of workaround that I had showed. So that could be one option where what you're importing inside of a edge type environment or into one of these is actually the output of another server. That allows you to cache these things independently, but your implementation doesn't really matter. So when I'm developing locally, I could just be requiring the actual federated runtime code in. But then in a server environment, I could say, well, what I'm requiring is the string that is the output from the other server. So now your stitching system almost, instead of having to like template on top of it and tie it together with ESI tags necessarily, you could say, well, just my React application is the edge side include setup. And I could just have the layout engine stitch, just convert the string back into something React-y and just do a simple render of it. If you're doing like full ESI, like you're putting ESI tags in your markup and you're having like a Akamai or something stitched together, that's something I have not tried, mostly just because I found ESI to be clunky or to have weird performance drawbacks as like the waterfall starts to get into place. So a lot of what I've tried to build out is how do I not need to depend on a vendor to stitch my application together? So I think it's totally possible, and it depends on how you have things set up and what the constraints are you want to work within. If you can execute JavaScript, then you could totally use Federation in a variety of ways. Yeah.
Okay, thank you. Now, next question comes from Pedro. When scaling MFEs with Module Federation, would you say that Medusa is a must-have, or can we work around and manage the orchestration without it in a simple way?
You can. Yeah, you can. What I would say, usually what I kind of say is, well, I've invested a lot of resources into trying to build out something that's intuitive. And so usually my proposal outward is, well, do you want to have to build out a GUI or something else to look at it? Or would you rather have the aesthetics kind of wired up and you don't really have to think about too much of the minutia under there? But you totally can if you don't want to use Medusa. Or, I mean, I think we also try to keep the SaaS cost really low. So it's not a try and get rich off of it, but it's more like keep the lights on and try to offer good value to the users. But yeah, so if you didn't want to use, say, Medusa for whatever reason, you wanted a really simple orchestration, the way that the simplest one that I would say is you could just have a JSON file, not even an API backing it, but you could just have a static JSON file up there and a little delegate module that just fetches the JSON and looks for its key in there and then finds, you know, whatever mapping you've got. Or you could have a simple Express server connected to a database that allows you to kind of control it, or, you know, wire it to a CMS or anything. Really, it's I'm going to make an API call somewhere. I'm going to fetch some JSON payload. And in that payload, it's going to have a URL to the right remote entry and the name that that remote entry would be under. And that's how you can connect the two together. So yeah, you could use it with a JSON file. You could use your own little API. With a lot of companies, I've seen the typical challenge is it takes a lot longer than everybody thinks to try and think about all the weird scenarios that you want to cater for, or like nested remotes. That's always a tricky one. And it's kind of hard to do nested remotes in a JSON structure because it can get circular and all of that. So how do you really create almost the algorithm to resolve what you're trying to do? But what works really well is when it's in a kind of a graph structure, which is kind of how you see how Medusa represents things. That's kind of how our relations work between it. So I can ask really complex, recursive, you know, circular questions, and Medusa understands the connections between these things because it's kind of simulated the full graph of all the builds on its back end and understands the correlations between things and where the boundaries are. So yeah, totally possible. You could do it with a little JSON file. I've seen lots of users just stick something in the window at SSR and then reference it off the window. So plenty of options there.
Okay, thank you for the comprehensive answer. Okay, then next question. Question from Ole. Do you think UI libraries will move towards publishing pre-built components on a server like some kind of micro-frontend as a service?
So I've had a couple interesting conversations with a few individuals around this idea, and it seems to be gaining a bit more traction as like, hey, well, why couldn't we? And it really does make sense, especially like I think, I haven't had enough time to look into React server components at the level that I should have. But, you know, I've spoken with Dan a little bit about it. I've spoken to other individuals who are very familiar with my ecosystem. And, you know, we're all kind of seeing a similar possibility here of, well, you could offer like hosted micro frontend as a service. I think even Joel Denning, he's the creator of Single Spa. I believe he was doing some interesting things around similar kind of scenarios within his stack. But yeah, I think there's definitely a potential to do that, especially like imagine the dream that I've always had is like imagine a Stripe integration or something where you don't have to iframe it, but you could actually have something that feels more like a tangible component that you could have some level of control over inside of, you know, not impacting performance, whatever. The drawback was always, well, what about the security aspect? You're now not wrapped in the iframe isolation. And I'm like, yeah, okay, that's a little tricky to try and figure out how you land it. So maybe credit card processing isn't the best for this type of scenario. But then server components popped out. It's like, okay, cool. Well, with that, you could have a hosted kind of backend provider, and you really just have some federation like glue code that allows you to bus little bits of info back and forth. But now all that execution remains on its hosted origin. You're not having to run the Stripe service here or anything like that. So definitely, I could see a big opportunity where we could get more prefabricated components that run more like services. The way I always think of it is like, imagine all those widgets that you get for like live chat or whatever that add, 2 megabyte Angular build on top of your React app, and it's one little icon. It's like, okay, well, those things, imagine if those followed this exact model. Cool, I'm only going to add 5 kilobytes of code to your app because you're React and I'm React. I could just use your React. Okay, awesome. That'd be amazing to see. So I think there's a ton of potential here, especially in vendor code, to make just more rich experiences.